Okay, in this podcast we'll be taking a look at how to determine x-intercepts, y-intercepts, and maximums or minimum points from a quadratic function that's been factored. So the first thing that we're going to do is find the x-intercepts. Well, the x-intercepts can be found by recognizing and remembering that all x-intercepts are points that are on the x-axis. All points that are on the x-axis have a y value of 0. Well, looking at the function in factored form, we'd think, well, how could we get a y value of 0 if we plug 0 in over here on the left side? What could we plug in for x? Well, based on the zero product property, which says that if you're multiplying things together, which we are 2 times x minus 5 times x plus 3, that we'll get an answer of 0 only if one of the things or more of the things that we're multiplying together equals 0. Well, we just think about these individually. If we have an x minus 5, what could we plug in for the x to get 0 here? Well, that would be 5. Well, that's one of our x-intercepts. A 0 here, 2 times 0 would give us 0. 0 times anything else would also give us 0. Well, what about in this linear factor? Well, if we used a negative 3, we would get 0. And 2 times something times 0 is going to give us 0. So our two x-intercepts are 5 and 3. 5 and negative 3, excuse me. So I'll make those marks here on our graph just to start to visualize that a little bit. Okay, well, what about y-intercepts? Y-intercepts are points that are on the y-axis, and points on the y-axis always have an x value of 0. Whoops. I'm going to have to do a little erasing here to get rid of this 0, because that is not the answer. The x value is 0. Well, to figure out the y value, we can actually go up to the function, use the input of 0, plug it in for x in both of these spots, and calculate the y value. So if we do that, and doing a little work in my head, we'd get 2 times negative 5 times 3, which equals negative 30. So our y-intercept is negative 30. Well, what about max or minimum? Well, I'll know a little ahead of time that with this leading to that this parabola is going to open up, and since it opens up, we'll be looking for a minimum point. So I can go ahead and write minimum here. Now the things with minimums and maximums is that for parabolas is that they'll always occur in between, exactly in between the two x-intercepts that we figured. And that's because parabolas are symmetrical and the max and minimum point lies on that line of symmetry. Well, between 5 and negative 3, that's a total of 8 units. If we moved 4 from one side or the other, we'd get an x value of 1. That would be one way to find the middle. Another way would be to average these two values. 5 plus negative 3 would equal 2, and 2 divided by 2 is 1. So our minimum is going to occur at an x value of 1. And then what we're going to do is what we did with the y-intercept. We're going to plug in that 1 for x. We're going to do 2 times 1 minus 5, and then 1 plus 3, which would give us 2 times negative 4 times 4. And if we calculate that out, we'd get 2 times negative 4, which is negative 8, negative 8 times 4, which is negative 32. So our y value for the minimum is negative 32. Well, thanks for listening, and hopefully that'll help you the next time that you're working on a problem like this. Thanks.